All right. Okay, we're getting through this day. Our next presentation is on CO2 LDAR, LDAR. Well, I'll let you explain that, Roy. I'm sure you've worked out all the cleverness of it. But just talking about fugitive emissions or fugitive equipment and right-of-way leaks. This presentation will be done by Roy Massengill and a couple of other colleagues of his. But Roy's background: air emissions testing upstream to downstream with locations in Fort Collins, Colorado, Tulsa, Oklahoma, Billings, Montana, Midland, Texas, Corpus Christi, Texas, and Houston, Texas. EnRUD provides source testing, mobile laboratories, and personnel to provide the industry the sampling and compliance source testing required for many emission points, including compressor engines, turbines, boilers, heaters, flares, process vents. LDAR is another service that they provide. Traditional LDAR programs, infrared camera inspections, high flow sampler testing and studies, component counts, GHG programs, field service, and mobile inspection software with legacy system integration. Hey, that's all about what you guys are. We want to know about Roy Massengill.
I'll get to that.
All right, floor is yours.
Okay. Yeah, I actually didn't provide a bio because so much information in my talks. Bios take up time. Okay. Been in the industry 30 years, and that is just something they pulled off a website comment. Or I may have provided in a previous talk, but I've been in the industry for a long time. What we're here to do today is we're going to set the stage for some emerging technologies or some emerging businesses. I just got to follow a lot of people on LinkedIn as you try to keep up with market development. BCG Group, which is Boston, consultant about it. Boston. I just saw an email from them. They're predicting I'll call it clean energy economy by 2050. We all hear those dates because of the meeting our carbon goals and things like that. $300 trillion. That was not a typo. Okay. Our GDP is not that. So we're going to have a lot of inflation. There's going to be a lot of economic development in the next, obviously, the next 30 years, whatever that is. And a large amount of that will be involved in making sure that we have an environment, oceans, or whatever you want to talk about, all the global warming stuff, the carbon intensity, what do we got? It's not just in the United States. We're behind. Europe's ahead of us. Canada's ahead of us. So as we get into some of the technology we're developing for the future economies, I'm going to, I've been keeping up with the market for several months as we've been developing this product. I'm going to just give you a flavor of some of the opportunities in carbon, reducing our carbon footprint. Let me go right into it. I got about 6 or 7 slides. I'm going to go too fast. But if you have any things about the economy, I can just tell you, just Google it. It's crazy. Okay. And follow stuff because it's changing every day. If you watch LinkedIn, almost every day we're hearing about another $1 billion project or several $1 billion project for either carbon transport, storage, direct air capture. This company committing to this many dollars to reduce their carbon footprint. So these people that say that electric vehicles will never happen, this isn't going to happen, that will just follow the money. Okay. So, and then trying to figure out from a business standpoint, how to get a piece of that money. Because after the construction phase, well, they're going to need services. That's what our business does. So that's sort of the thing here. We're way early, but you're never early enough. Think about it to prepare for something that is going to be up to $500 billion in the next 3 to 5 years of construction. That's not necessarily the inspection side, but they'll need services. We provide services as an industry. So that's sort of my take on the introduction. Okay, just an introduction to CO2 so you can begin to understand CO2. It's mined in some salt domes over here in Mississippi. That's natural CO2. We use it in dry ice, refrigeration, HVAC. Been around for years. We found it looking for oil. And the next thing they got CO2. So we needed it, and they monetized it, right? These are 50 years old. These natural resources are 50 years old. We're running out. It's a commodity that is actually going up in price. Okay. Think about it from this side. We pay to bring CO2 out of the ground. And we switch around and do this, and then we pay to have it injected. Okay, so we want to monetize and merge those businesses from the business standpoint, which means we're going to capture, transport, store things in vessels and pipes, which you're getting a carbon tax for, which I'll talk to in just a second, to be green. So if you're going to sequester and store it, it better stay in the pipe. You're getting a tax credit for it. So that's sort of the mantra. I'm working with DOT and other people that are going to be regulating, just like we had Part 195, which I have some slides on that in a minute. And so the economy's happening. Do I know it's going to require some type of inspection? No, but PIMSA, if you kept up with that, the mega rule, they actually, in a pipeline integrity type of act, talk about the need for some type of inspection, drones, aerials. They mention these by word, or negative pressure wave, if it's liquid, things like that, right? So it's already being brought into DOT. DOT is now going up for public comments and will have meetings in the near future on regulating gaseous pipeline. Okay, which I have some slides on that, but I'm sort of setting the anticipation of what's going on. And these will be required to be manufactured the way DOT regular things, regulated to have certain safety standards through PIMSA. Okay. I've been in touch with John Gale, who's director. I'm trying to keep up with that. And I'm actually trying to see the market from a business standpoint. Say, hey, we have a device that can detect it. So as you follow the PIMSA template, okay, we already have a mechanism to check right-of-ways to see for low level, small leaks at the PPM level before it gets to a critical failure. Traditional demand, anyway, as I go back, stick to my slide here, traditional demand, food and beverage, medical fabrication, HVAC, fire extinguishers, and EOR has been the major driver for all the pipeline infrastructure, going from New Mexico to the Denver or Colorado area down to the Permian Basin, and then Denver is the big player over here. Denver is the big player over here and up here. So your EOR is the big driver, or currently that's causing a supply demand issue for CO2 for the consumer type of things. Currently, in the US, we have about 5,000 miles of CO2 pipeline. We have hundreds of thousands of miles of lines of gas or more. So it's real small, okay? But it's going to grow exponentially like this. The biggest thing is if the Democrats want this green stuff, we got to speed up the permitting process for pipelines. If you've heard about that in the news, right? Most of the CO2 is piped. It's in a supercritical state, which means it's liquid. Okay, at a high temperature, high pressure, it's not really liquid. It's not really gas. It's in a supercritical state, which is really a combination of both. But have you ever wondered why they use an EOR in its supercritical state? It has no surface tension. Well, what does that mean? If you got permeability, porosity, and you're trying to get the liquids through it, you got to have a lot of pressure because we got surface tension in those small pores and in the permeable spaces. So what's the magic? Why are they using CO2? Well, it's because they inject it in a supercritical state, goes down there as a liquid / gaseous phase, right? Then comes back up as some froth, dirty thing like you see at the beach, the scum, right? 95% CO2, 5% water and oil, right? Separated, clean the CO2, go back down and do it again. We got to do makeup. So the EOR industry is, if you like, I'm a geologist by trade. To me, it's just really incredible the technology put into that. When we start to gather this stuff, it will be in the gaseous phase. Hence, the DOT has already been looking at regulating that part. And part of the permitting process, if I have my way, it's going to have some type of inspection. May not happen, but that's how you set up the business. You see the market. And just to get an idea of what goes on over here is we have atmospheric CO2, carbon-based fuels burning. This is some of the potential capture products. So ethanol plants, biofuels. If you look at what's going to happen with biofuels, with the energy, with the IRA, which was the Inflation Reduction Act, which is really was an energy bill, a clean energy bill, if you actually think about it, right? You got refineries, chemicals, cement, huge carbon producers, right? So we're trying to find a way to capture that or put it back into concrete or into other sources to keep that from being, out into there. And now we got a tax credit, which I'll talk about that in a second. natural gas processing, we got combustion sources. And then, of course, the all this would go to the carbon capture facility. And it's either stored in non-conventional formations, depleted reservoirs, or used for EOR. The EOR tax credit is a little less than the others because we're not really sequestering it, we're using it, right? For basically oil production, which I think liberals, in the political sense, the other side hates oil and gas, right? So you don't get as much tax credit, but if you're selling the oil and your ROI is 40 and you get $26 for tax credit, but then your oil goes up to 80, holy cow, even the EORs are doing well right now. So what you'll see is all these conventional depleted fields, because they get a tax credit, we're going to have a burgeoning of EOR facilities from all our majors, miners, everyone, not just your Denberries, not just your Oxys, Kinder Morgans and Chevrons, and the majors have some. There's going to be a real focus for EOR because we're going to give them money, which takes their ROI in billions of dollars for these things.
Go ahead, real quick. So that you can store this in a salt dome.
Well, yeah, you can store it in a formation that has a cap. Okay.
Of course.
Okay, in salt domes, because of the way they protrude up, have a cap.
And
And saline formations that have a seal, usually a shell.
CO2 is one of the things that they will use to help increase the productivity of the house.
Tertiary,
Is that what they're injecting? in
well,
there?
well, yeah, remember, we got primary production is the first thing, and then it drops down. They bring into a water flood called secondary, right? And then once they can't get any more oil out of that sponge, they either sell it, stop production, they think of where the price of oil is, because you have to have pipeline infrastructure, certain things. And then the tertiary development is EOR, enhanced oil recovery, CO2. The United States is about the only one who does it. Other countries don't do it. The Netherlands, Finland, they don't even allow you to do it.
What percentage more can you get out of the well?
About 40%.
Oh, okay.
Yeah.
Dang.
You think about it, if you were to dunk your sponge in oil, okay, and wring it out, it's still black. Okay, so we're getting that residual stuff because our surface tension won't allow the pressure to actually squeeze that sponge, and I use a sponge analogy, right? So the CO2, there's whole bit, Denbury makes their living at nothing but EOR. Other companies increase the life of their field, try to get an ROI. When oil was $20 per barrel, you're losing money. When it's up here, and there's been some increasing efficiency, it may have dropped, and it may have been 60 at one time. My information, I think it's around 40. So if you got oil at 80, and the government's going to give you tax credits at 26 for whatever, that's based on megatons per year, right? Type of thing, or megatons you actually capture or use, right? So you're just adding to your bottom line, especially if you're already in the EOR facility, you just fell into it. Think about it. So it's a profitable business model. And now I'm talking from the business side. They're going to get technical on it. Okay, we've been hearing about it. Wow, here it is. That's what I'd say. This is, as I started looking at this for 3 months, as I started developing this, trying to figure out, is this viable? Because we're not going to do it if we can't make money, right? If we don't believe there's a market, we're not going to do it. So in 22, we started doing the most amazing thing happen. We spent as much money on green energy transition as we did on fossil fuel investments. So that we actually spent more, they said parity, right? So moving forward, the IRA passed, I can't remember what year it was, things are made probably late 21, it may have been 22, can't remember, but it came out with fanfare, right? And you're going to provide with $300 billion of credits between solar, hydrogen, ammonia, direct capture, and all these energies. Well, all that stuff has to be transmitted somewhere. We're going to have pipelines built. Okay, we're going to have facilities built to it's going to be across the food chain, because after you capture it, you got to do something with it. Either you monetize it inside the current supply demand for carbonated beverages or whatever. There's going to be. I've heard right now they're coming up trying to figure out taking CO2, whatever they hydrogenating or whatever they do with it, water, making methanol. Actually a use for it. And they're going to get a credit for that. At the same time, make money, because on the supply side, you're allowing them to get a credit for it. So it's amazing the economy that's going to be built around carbon minimization. The EU president, probably, I think it was 3 weeks ago, he's pushing for, I can't remember his name, but he's pushing for, he sees the USA doing the IRA. Well, they can't be competitive. So he's pushing for the European Union to do a net zero act. I'm going to have to speed up. Okay. Sorry. Good. So UK just announced that the IRA, they're going to have their own IRA in 2023, hopefully by the end of 23. So these other foreign companies that are ahead of us have been, as far as the green economies, for now I think they're behind us. So they're going to run their own bills. It may not match the 300 billion, but we're going to have another spur of investment. Not only United States, Canada, European Union, UK specifically is going to have their own. So my thing is the snowball effect has started, and they're allocating a lot of dollars to it. And if you don't think it's happening, read the news. It's happening. It's hard to read, but one of the things that's a catalyst for it is the IRA. And I'll tell you what it is. So basically it increases all the way up to year 2026. In 2020, it was $22 for EOR. In 2026, it's going to be 35. Straight to the bottom line. Just increases every year. And from an economic standpoint, you got ethanol, cement, refining. I'm going to go through the different industries. As that tax increases, more and more industries, ROI reaches it, so they're going to fall in line. If you can make money doing it, there's no more reason not to for your investors. So we're getting close to that ROI once we hit 25, 24, and 25 is what I've read as I've read so much information. I feel like inundated. There's a lot of information out there. Here's one of the things that is interesting. We're going to have CCS hubs, pipeline infrastructure built all around the United States. They're going to be in oil basins. What land do we know more about what's below the earth than where we drill for oil? We have geophysical data, we have well data, so we know where the good places are to inject it into a saline formation, do EORs or is there a trap under there that can take care of it. So, and you put it near industry, so we're going to have stuff. We're going to have stuff obviously all around the Gulf Coast, up in this area because of the ethanol. We're going to have plenty of things to take care of the ethanol plants. So the economy is just blowing up. Okay, that's all going to be built. You got pipelines, storage, and then the actual capture of it as far as infrastructure. I got this from another source. There's tons of sources out there. This is Decarbon Views, which has a database that tracks all the carbon capture information out there. They provide it on to construction companies and things like that on a fee basis. I got it for free, but just to, because it's a burgeoning economy. They're trying to figure out how to get their information out. But this is just one that they're talking how they reference the sequestration. It's called a hub that they're going to have around the ethanol plants up in the Midwest. We'll have one in the Gulf Coast. We already got one in Louisiana. Corpus is going to have one. The Permian's probably going to have 3. Okay, it's going to be one hub at 3 separate places. Okay, supply demand. I wanted to touch on this. Why? Well, not only that, CO2 is dense, 1.5 times as heavy as air. When it leaks, okay, the disaster in 1986, I actually did a research paper in college about this, so I remember it specifically. It killed 1,700 people. It was a volcanic lake that turned over, right? And because of the depth and CO2 slowly sleeping down here under pressure, they say it may have been a landslide or something caused it to start. Then as it went back up, it's almost like a gas lift situation in an oil field. It went back up, created its own, fed on itself, released, they have it up there, 1.6 million tons of CO2 that came out of the volcanic lake as a slug and went down the valley and killed 1,700 people. All the villagers, all the life, they walked up there the next day and all they had were animals dead, no physical thing. So as they did research, it was CO2. We had a pipe rupture in Mississippi a couple years ago by not to be named company, but it was huge. blew it up. I saw the stuff. DOT, PEMSA, safety, not DOT, the Safety Administration, the local people, responders. 50 people were hospitalized, 300 evacuated. It could have been worse. They shut down interstates for 2 days. They were trying to figure out how to respond. They didn't have a good enough spill response plan or there's another word for it, but a PHA, process hazard analysis, right? And they were fined $3 million. So they're looking for a way to periodically check their pipelines, right of ways, and also their EOR filter cells, as we're using existing wells to inject to bring things back up. Some of those are old, depleted fields, and the casings may be going bad. So without going too much further, I'm going to back away so we can actually get into the technology and how we're developing it. The possibilities, if you dream, which I am, right, are incredible for this new, it's going to be a new economy. And so that's what's prompting us to develop some of these technologies and see if we can't, provide services to that industry as it develops.
Get that slide up.
I'll hand it off.
Okay.
I
I
get
might be
carried away.
better off just sitting here because Nick's gonna get up much longer than me. Brian has done a great job of introducing technology and the needs. And so I'm able to skip a whole bunch of slides that I have followed. So we can save some time. But I wanted to focus on the 2 bullets from the bottom. That's what we're addressing, is as the carbon dioxide pipeline infrastructure grows, which it's going to grow and it's going to grow fast, detecting leaks, pipeline integrity is going to be as critical as it is now for natural gas leak detection. And natural gas leak detection is a role that we've played in for 25 years as collaborators with consultants who does natural pipeline leak detection worldwide. Sounds actually works.
Just a second. There's a pop-up window here. Try it now.
At the end of the
I
slide,
have to push it
I
back.
had it more present, more slide.
Page 6, I see on the far right.
Try it now.
There I go. This is a little description of us, Physical Sciences Incorporated. We're basically a contract research company, but we've developed technology that are embedded in a variety of products that's based on tunable diode laser spectroscopy. A little bit in a second. But these are products that we have developed and are commercialized primarily through consultants for natural gas leak surveying. Worldwide standard now, the RMLD CS version of it now is sold worldwide. There's several thousands of them out there in the world doing the survey. These are other configurations. We've got airborne sensors, we've got mobile sensors, drone mounted sensors, and fixed open path sensors, all based on this technology. I can tell you again why we need it. Like I mentioned, carbon capture and sequestration happening. Pipelines are being built to bring carbon dioxide from their sources into and basically inject it through EOR or gas storage ground. And lines are going to be inspected. I'm not even going to go through this. We've been doing this for 10 years. Secretary of Energy talked about the value of lasers for detecting carbon dioxide and methane leaks 10 years ago. Basically talking to folks like us who call ourselves lasers for us. But here's the fundamental technology for leak inspection. Is a laser beam, much like pointer laser, going infrared, so you can't see it, shines through a cloud of leaking gas, methane, carbon dioxide, what have you, shines, on a surface, and just like you're seeing this red beam now, it backscatters light, and we can detect that backscattered light, and the gas that you're looking at absorbs some of the laser power. And we measure that change in laser power as a measure of the amount of gas in the path of the laser. Sort of shown here, you send your laser out, it scatters back, goes back into a detector. That detector probably tells you how much gas is in there. And it's fast, it's very sensitive. We get small, let's per million detections, and we can figure it in many ways. But for carbon dioxide and methane sensing, each one of the sensors works at a specific color. So this is a red laser. Our lasers are infrared, you can't see them, but the color is quantified by a wavelength. So wavelength for methane detection is 1650 nanometers built into the RMLD. Carbon dioxide, there are wavelengths in nanometer range, slightly shorter wavelength. At that wavelength, we are getting sensitivities on the order of a couple of orders of magnitude, not as sensitive as methane detection. And the instrument that Nick is going to show off in just a minute is operating at this way. So it's not yet a sensitive. There are other carbon dioxide wavelengths that we have built handheld sensors like 10 years ago that are as sensitive as the methane. We built the unit that Nick is going to show in a minute, specifically to have it ready for this show, using components that we had off the shelf, and we didn't have a laser at that wavelength built into it. That's the next generation. I'll show you some data, but we won't have time to look at it. So I'm sure to see how that. But so that will be happening at longer wavelength. But what we wanted to show today is, comparison between methane sensors, carbon dioxide sensors. Background is we have that up here. So this is the product that is on the market now, sold through heat consultants. Called the second generation of RMLD. Formerly was a two package unit. This is all one unit. It's got an example of the package here. And that's used worldwide for surveying distribution pipelines. And it's got 5 ppm sensitivity and all kinds of alarms and bells and whistles in it. And it does capture video images, pictures on the side, and in a product doing workforce of detection for municipal. 2005, 7,000 service. And recently, and Nick can talk through this slide himself. Yep. I can push buttons for you.
Sure. So yeah, what we've done recently is we've taken the technology underlying the RMLDCS, which is typically, or which as a standard, it's using a fixed beam, fixed laser beam. So wherever you're pointing the laser or system is where the beam is. In this system, we've upgraded it to have a laser scanner. And so that laser scanner, sort of cartoonized here on the right-hand side of the plot chart, it'll essentially do a raster scan over your area of interest. So right here, you can see it's sort of rastering over a cartoon valve. And so each one of those spots during your laser scan is received by your detector, and you're able to restitch each one of the spots into essentially an image. We're calling it a concentration image. Pairing that with the camera that's embedded in the RMLDCS as it is, we can then overlay that concentration image onto the visible image, as you can see here, and then you're able to actually visualize where your leak is at. So in the field, the con-ops for the RMLD QDI typically be you're operating it in survey mode as you would in RMLD CS. You're scanning from afar, trying to hunt down where your leak actually is from a course standpoint, so you can operate longer distances. And then once you get that leak hit, assuming that there is one there, you can switch to an imaging. And then at that point, you get closer to your leak, so it's based on the initial detection, it's not at unsafe levels. You can approach your leak, switch to imaging mode, and then more precisely pinpoint the leak location, whether it's going to be a flange or that, what have you. And then once you've actually pinpointed that leak source in your image, you can center that leak in your scene, and then enter what we are calling quantification. And then we'll compare that image data, that concentration map data, with wind information, whether it's from an anemometer or from an algorithm-based wind estimate. Then we can estimate what the actual flow rate is, and we report that as our flux value, which is 10 in this scene. But that's a capability that we have. So that'll report right now in terms of cubic feet per hour. And so we've taken this technology, and I'll just do a quick demonstration here. I have 3 bags filled down there. We have one with methane, one with air, and one with CO2. We have methane and CO2 are they're pure. So when I'm operating in survey mode, if you are familiar with the CS, it will do an audible alarm upon getting a leak indication. So one of these bags, the leftmost bag, has the methane, and so the other 2 after. And so taking that technology and essentially swapping out the laser, as Mickey described, for an appropriate wavelength for CO2, we can do the same thing. And Mickey, do you want to switch to the next slide? So if I switch to the survey mode again, I can start with the leftmost bag, which I remember that was the methane bag, the trigger, the center bag, which is the air bag, the trigger, and then the rightmost bag, CO2 bag, and trigger. And so that's, again, using the same type of technology underlying the RMLDCS. We certainly encourage you to come stop by the EnRUD booth, check out this guy. I can show you it in imaging mode. I also encourage you to come by the heat booth to check out the RMLD QGI. Sean will be attending. And so that's the essence of this. And so we see this, as Mickey said, right now this is a lower sensitivity variation of the technology. Once we get the 2-micron laser in hand, we can improve that detection capability and the quantification capability to detect leak rates only comparable to what that, I will leave it open to questions or transfer it back to Mickey for even more.
I think questions would be more appropriate than going through the science.
My guess is that there's a lot of low-hanging fruit out there. Drive.
I know a lot of work for Denbury and some other EOR facilities. And I actually knew for, even because they're for, yes, that's your question.
So the sensitivity, if it comes into the picture in the next couple of years, you can get this thing to market and find a lot of.
And let me tell you, physical science has been incredible work. I've been talking about, you had a previous job, I've been talking about CO2 forever. Like, from the OGI camera, I need a solution for CO2, okay? Because I got people out there that are looking for 5% methane. Have you ever done that? Anyway, it's tough to see 5% methane, okay? Or lower, right? So I'm detecting 90% CO2 because it's still under quad O with an OGI camera. I can open up an open-end line, have it poured out so you can hear it. And I don't see any absorption. All I see is a boundary layer of clear movement of vapor, right? So we're not high enough concentration in that long equation. They always talk about it. If random gets to it, all the land of Greek alphabet, right? We're not having enough on that one part to get absorption, though I can see it. Okay. If that's because we're looking for methane. Okay. Well, I know I can keep their CO2. I didn't know how much it costs at that time. So this is insane, but I'm complying, right? So as I start to understand the CO2 market, I go here, full circle. I approached them about 2 months ago. Everything you see came from an idea to this 2 months. We ordered a laser, couldn't get in here in time. What can we do? He goes, well, I think I got something in the back 40. Okay, that I used for research in Illinois, Decatur, Illinois, I believe, or something like that. He told me the story.
Right.
And so he took a piece over here, a piece over here, and allowed us to present something or envision. And from a marketing, we call it Gen 1 to whet your appetite. The laser is going to be here. The scientist, who we trust a little bit, right? And he's done studies on it, say that. So the package is set up. Packages should work. You know how I feel about should work. I'm gonna prove it works and tell the sensitivity in grams per hour, similar to LDAR programs, 5 grams, 60 grams, whatever the grams are, determine low detection limit on that, and have a survey tool. At the same time, they say they take same technology and integrated imaging of a plume on it. Since we're already at Gen 4 or whatever with the methane, that technology is already available. It's absorption, right, for them. So the development of the tool can be sped up through that. Not that it's cheap, but it's what it's done, right? And then the last thing is just another thing. We got the flux figured out. They changed their algorithm, do their studies. Next thing you know, we can quantify. Okay, how accurate? I'll let you know. Okay, but even the other quantification for OGI, QOGI, and things like that, there's an error in there sometimes, depending on who you talk to and selling it, right? 20 to 80%. So it's just a tool that I think has a lot of possibilities. And so I'll sit down and let another question get asked.
You have about 3 more minutes.
No more questions. We certainly appreciate your time. Thanks for attending.
Really encouraging. Yeah, that was very informative.
Yeah.
Yeah, and if you're a businessman, all you got to think about, there's, for that number 300 trillion came, throw that aside, 500 billion. I actually have the IEA database. In the next 5 years, projects, okay, 579, it's one of the slides, I passed through it, right? 579 worldwide, 100, I'm throwing out rough numbers because I don't have it in front of me, right? 170 in the US. 8 of those projects, that's all, reached an FID, final investment decision, okay, in 2022. And then they have a list when it's post-reach final investment decision, another 80 in 2023. That don't mean it to happen. You've all seen the financial, but there's a high probability that some of those will happen. That is like that.
What is it costing right now per 1,000 people?
The ROI, it's a commodity, okay? And I Googled it, okay? And
Gas is at running something right now per 1,000?
you know, I was trying to figure out, okay, it costs CO2 for that. They give me dry ice. I'm like, yeah,
Oh,
I got to get ChatGPT working or something, you know, I don't know. But I'm trying to do that right now because from an ROI standpoint, that's the missing thing to me. But again, we're getting tax credits for being green. I think that's not the only driver, although as a business, okay, that is a very strong thing. If you can show, you can pay for the program a lot, like the old steam trap programs, right?
The other thing that struck me too is the deaths that occurred. There's a safety issue associated with this.
CO2 will kill you. That's how you commit suicide, if you want to know. With the car, right?
I thought that was CO.
That's carbon dioxide, yeah, but yes,
It's like CO2.
it's an asphyxiant, yeah. And because of its density, okay, that's what happened in Mississippi, that happened there. If you have large slugs, we'll call it, because the density, that slug stays together, it doesn't disperse.
Is it quick death?
It's asphyxiant. I didn't Google it, sorry.
That's guys.
Got something in mind?
No, it's slow.
No, I mean, it's like H2S, boom, down.
No, it removes
I haven't heard
oxygen,
of that.
it removes oxygen from the air, so that's.
I got you. It's not great.
Yeah, there's no oxygen. So, but yeah, we're excited about it.
So, Roy, happy hour, 5 o'clock?
Yes, we're sponsoring Women's in Energy Network. event.
Thank you for your time.
Oh, absolutely. Thanks for coming.
Is that
Or
women
Pardon me,
only?
I'm sorry.
No, yeah, put your skirt on. You talked to Robert Williams?
Yeah.
He said, that's just, no.
Starting your happy hour now, so you can go with me.